Yo, today's video is about me showing how to make a Beyblade physics system based on humanoid movements. Okay, that's very complicated. I'll just show you. First of all, you need a Beyblade model. You can find one in like Hasbro somewhere. There's lots of places you can find models. So first, we want you to create something called Beyblade template with a humanoid, and then with another model inside of it called visual. Now we need your Beyblade middle, uh, tip, and the top, basically. And then we need you to create a center part that's invisible, transparent. And we need a hinge attachment. Now you weld all the parts inside of your Beyblade models, all the meshes, like, to the center, because the center is actually the one that's doing the movement, the rotation, all of that. And you need a hinge attachment. It's basically an attachment, and you name it to hinge attachment. That hinge attachment is gonna be used for the other hinge attachment that is in a humanoid root part of the Beyblade. Then we want you to add a vector force called downforce, and the downforce attachment to attach the downforce to the parts, or the center part in this case. Then we need a spin hinge. The spin hinge has a motor which actually makes the Beyblade turn and all of that. It's basically the engine that gives power to your Beyblade. So, first of all, we want to test the spin system. So, how do we do that? You say, open script, rename it, call it spin test, delete that shit. Also, the orientation is very important, or it's gonna break everything. And also, everything shouldn't, like, anchored should be false, can collide should be false, can touch should be false, can query should be false. For like all decorative parts and center properties. The center should be also transparent. Now, before adding any movement, we need the visual assembly to spin independent in the okay, my English is gone. The invisibles to this is for like the invisible root stays stable while a hinge motor rotates the visible Beyblade. We're gonna create a script which is called spin test, and now you write local Beyblade equal workspace. Wait for child Beyblade. Nice. Local root equal little with child this, but then you need to add humanoid root part. And then you're gonna say local hinge equal root wait for child, not hinge constraint but spin constraint. No, spin hinge. Spin hinge. Now you're gonna give it stats. So hinge dot actuator type equal enum dot actuator type dot motor. Then you go hinge daughter motor max torque is gonna be equal to 10,000, and then hinge weight dot angular velocity is gonna be equal to 60. So basically what this does is, you see this Beyblade in the workspace, it makes it spin. Now Let's see. Yep, and it's spinning beautifully. That's actually even smoother than my game. What the hell? Okay, this is it. This is the very first simple step. Now, disable the script. Go ahead to server script servers, add a script, rename it. Now, before adding any inputs or anything, we're gonna create a script in server script service and we're gonna call it Beyblade server. Delete this. Now, we're using a humanoid system and I'm gonna show you how to supply movement. So basically what you're gonna do is local run service. Give me a service run service. Local replicate storage get service replicate storage. No. Local workspace. Wait, that's wrong. Workspace. Target workspace. No. Local Beyblade equal workspace. Wait for child Beyblade. Local humanoid equal Beyblade wait for child humanoid. That's right. Oh, local root. That's actually that's wow. That's also right. Okay, nice. Local hinge equal wait for child spin hinge. Right. Yeah. Wow. Real good. Local downforce equal root with child downforce. Nice. Now you're gonna add the stats. So move. Oh, move. Speed is gonna equal 55. Local downforce equal. That's a lot. Like 260 should be enough. I believe so. Now you're gonna do humanoid dot walk speed equal move speed humanoid dot jump power. No, that's right. Humanoid dot auto jump enabled. We're gonna make that equal to false. Then we're gonna need what more do we need? Oh yeah, uh, humanoid dot. I think it was auto rotate equal to false. Then hinge. Actually, copy this from here since I'm too lazy. No, okay, I did the same mistake. Now run service heartbeat connect function dot heartbeat connect function humanoid slash move. You can use so basically move, you give it like a certain aspect and it moves to it. But if we say move to, then you can set like checkpoints and then the part will move there. It's cool if for like path finding systems, but for here it's not really that good, or like we don't use it much. Vector.3 dot new. Nope. Yes. 0, 0, -1. False. I'm gonna do local velocity. No. Root dot assembly linear velocity. Local horizontal. Wait. Speed is gonna be equal to vector 3 dot new. Okay. I'm gonna say velocity x, and then you're gonna say 0, and then you're gonna say velocity dot z, and you're gonna say magnitude, and then you're gonna say okay, local equal mass dot horizontal speed slash 60 by 0.8 by 2.2 should be enough. Zero minus root dot assembly math. And now you're gonna put these two in here. Oh, 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 okay, sorry. 0. Then you're gonna close it with sub, and I believe that's it. Now, what this is gonna do, according to this direction, to this move, it's gonna move to that way. Basically, that's it. So, walk speed supplies the movement speed, which is here. Vector force is basically what keeps everything on the ground, so it won't fly, bounce, and all of that. You can also do mass.huge or mass.max if you want to be just sure, but then sometimes it can phase through the ground, so we don't like to use the very huge numbers. Now, what this should do is, okay, as you see, it's going till eternity. Basically, that's it. Now we have a working movement. So now we're gonna add player input, which we're gonna put in here, here. It's gonna be a local script. We're gonna rename it and call it something simple, beyblade. Oh, local run service. Before that, we need the local. And then we need this, and then we're gonna do local. And now, local function get input direction. No, local function get input direction. Local space current camera. If not, we're just gonna like do a double check. Not camera, then and then we're gonna go. Actually, don't need this. We're gonna do local for what word equal vector 3 dot new camera C frame look vector dot z. Then you're gonna do local right equal vector 3 dot new camera dot C frame. It's basically the same thing that I'm gonna do, but right vector instead of look vector dot x, and then 0, and then same thing. Oh, got this. Now, if we do if forward dot, we're gonna do magnitude. Actually, where is this? To be fair, I don't actually know. My mistake. 0. Then right should equal right dot unit. Now you go and say local direct di wow, I'm stupid. Wait. Local direction equal vector 3 dot 0. Then direction that's right. If it's A, that's right. If it's D, wait, local direction is 0. If it's A, it's gonna be right. That's right. Direction right. Now return direction dot magnitude 0 and direction that's 3 or vector 3 0 and okay, that's nice. Then you say function humanoid does move get input direction false and that should be about it. Also, we need to go back here and we need to remove this. Where is it? Now, this should technically, okay, see, I haven't done the camera, but that's basically it. As long as, like, actually, see, and it's great. And here's physics for you, bro. Now, so basically, this is uh, the WASD movement that we see in every game. Next, we're gonna go with something, we're gonna smoothen it out. So, how do we do that? Actually, how do we do that? Wait. I'm gonna check this out. Okay, so basically what we're gonna do right now is gonna smoothen this out. We want it to be better, smoother, like it's sliding on ice. What we do is get to line 6 and you do something. I think we do. I don't have this memorized. Local smooth direction equal vector 3 0. Then you're gonna do local steering 12 maybe. Definitely not 120, but like 12 should be good. And then I'm gonna do local. This is like to show to make it smoother and like to like show drag because the Beyblade doesn't actually like stop instantly. Let's do 8. Local function get input direction correct camera. Blah, 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 blah. You should we should do DT for this, and then we should look instead of get input direction and then false, we're gonna do get input direction. We're gonna do local smoothing. Wait, wait. Smoothing speed equal no equal input direction magnitude. No, 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 no. Okay, I got this. 0 and do like no get wait function dt wait function dt local or stop speed and now I need to get yeah right and then math min that's in reverse so dot min 1 moving speed, and then dt. Now we're gonna do if smooth direction. It's also just like a double check. Dot magnitude 0.01. That moves smooth direction. Okay, smooth direction dot unit dot false. That's how it needs to be. That unit that false. Else smooth direction equal vector tree dot 0. And I made that vector tree 0. I don't need a false right now. That's literally unnecessary. So now we have acceleration. So basically we start slow and then the speed increases. That's what acceleration is. Let's go in. Go. Wait, let it load, let it load, let it load. I didn't do any mistakes. Okay, I did a mistake. And a very bad mistake. What do you mean I did a magnitude? Where is this? This is 961. Oh. Very simple mistake. Uh, sorry. Now we're good. With no problems, yeah, okay. Now you're gonna see it. Please just chill. I just You see it starts a well, it's always fast at this point, but like I think you get my point. The reason why it gets further and further away it's because of how accelerating. But yeah. No. See? The stopping. So I stopped, but the Beyblade continues. Wow, this can actually be a good idea. I don't know if anyone is gonna like implement this, but yeah. And that's drag, friction, and whatever you like to call it. It's basically acceleration and then deceleration. Well, this is good, but we're not finished yet. We're still at like the half. What we're gonna do now is this was part 5, I think. It's smooth movement. Now what we're gonna add as in Babel controller is I think at the top somewhere, local root, local root, local root. Okay, so what we're adding now is leaning and or tilt, I guess. Tilt, yeah, tilt. First, we're gonna go to the top section of the script, right at line 6, local humanoid. We're gonna say, we're gonna add two things. First, local root equal beyblade for child humanoid root part. That's right. Local hinge attachment. Logo for child hinge attachment. That's also right. Okay. Now below steering speed, I need to find local base spin and okay, yeah, here. We're gonna add three things. So basically, local base, no, pin, C-frame equal. C-frame angles, this needs to be equal to C-frame dot angles 0, 0, mass dot random or rad or whatever the fuck you'll call it. Should equal to, I think, 90. Then you're gonna say local max tilt is gonna be equal to mass dot rad 24. Of course, you can change this. You can add your own values, whatever you feel like it's the best. I like it fast. I like it extreme. Local smooth equal dot new. No, that's still not accurate, but 1. Now, after get input direction, but before like the heartbeat connect, me trying to remember this is actually hard. What the hell? Where exactly is this? Let me think. Was that the top or like right in the middle? It's supposed to be like after like get input direction and like before the heartbeat, and we need to call it like DT. Um, okay, so basically you go here, return direction, right? And if we're gonna do if 0, then we're gonna do this. Return direction dot unit. And then you're gonna do something called return vector 0. That's right. And now this is the big change. Local wait, local function. We're gonna do update lean dt, and then we're gonna go and do local velocity. The linear velocity. Yeah, but not in that way. We have a different format. This, which is this, and then this, and then this. And we're gonna do this. Then we're gonna do local speed equal flat velocity magnitude if speed big or equal, no, equal 3, then we're gonna need the hinge attachment to return to base spin. Hinge attachment dot frame equal spin frame. Turn end. Level of smooth tilt direction equal to smooth tilt direction lerp direction. No, we need target direction. That's dot minimum is gonna be about 162 dt. Simple mistake. And then if smooth, why do I say smooth? Okay, smooth tilt direction magnitude, blah, 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 blah. Smooth tilt direction is gonna be equal to bomb. Uh, bomb, then 0.01, then return Then you're gonna do local target direction equal to smooth tilt direction. Smooth tilt direct. No, local target direction. Direction then dot unit. Local speed ratio equal math dot. I think I need a clamp right now. B slash math dot max human work speed. I think local tilt mount equal maximal speed ratio. Speed ratio local direction equal root vector to object space smooth tilt direction. Then local tilt axis. Okay, no, actually no. Equal vector 3 dot new tab local direction dot z tab hinge attachment dot frame equal frame dot from axis angle tilt axis, and then we're gonna do minus tilt amount. Base spin C frame. You can get rid of this because it's useless. Now, run service, heartbeat, connect function, DT, local input direction, equal get input. Speed equal input direction, magnitude smaller than zero, and steering speed or stop speed. Smooth direction, lerp. Input direction, mass min 1. If smooth direction magnitude, then human false. Else smooth direction. Else and okay, we need to call this update clean. No, the clean DT. So basically, this is the tilt. We're gonna I'm gonna show it to you right now. This is movement based leaning. So basically, I'm gonna show you right now if no errors, please. Let me see. Seems like no errors. Okay, though I think we're good. Oh, well, let's first. You see, it tilts right now. It's a bit in reverse, but that's how I like it. Okay, wait, it actually disappeared. What the hell? My fault. You're gonna see it. It does disappear, of course, into the part. The thing about tilting that you need to keep in mind, if the tilt is too much, like I'll first wait to load, as you can see. This is like an extreme tilt. I like it extreme. Of course, when you first start your game, you're gonna see like a lot of phase twos, but that's the tilt. Now that we're done with the tilt, we're gonna go to orbit movement. But that's for the next part. I'm not gonna do that today. It's 3 a.m. right now. I need to sleep. So I'll do that tomorrow. See y'all. Peace.